Good morning, class. We are going to be taking a look at section 3.5G today, which is more practice with some multiple step equations. Just like yesterday, you're going to see, or I should say just like on Friday, you're going to see lots of different types of equations put together in one day. It's going to cover all of the different things that we've seen so far. And there's multiple steps to all of these, so they are going to look a little long as we start working through these. All right, as we get started on this one, I notice there's no fractions or anything weird I have to worry about. All I'm really looking at on this one is that I probably have to start with some distribution. So let's go ahead and distribute the 10 on the left-hand side. 10 times our 2x will give us a 20x. 10 times our 4 is going to give us 40. And that should equal, on this side, we're going to have a positive 8 when I take a negative times another negative. If it helps to put that negative 1 out front, you can. And negative 1 times our negative 9x is going to become a positive 9x. And plus 3x at the end. Notice that on the left-hand side, I don't have any like terms to combine. But on the right-hand side, I do. So we have multiple x's that we can put together. So I still have my 20x plus 40. And then on the right-hand side, I still have my 8 plus 12x. All right, at this point, I have no other like terms to combine, so let's go ahead and start bringing pieces over back and forth. I notice, for example, to get all the variables to one side, I'm going to need to subtract my 12x. Whatever I do to one side, I know I'm going to have to do the exact same thing to the other side as well. So this is going to give us our 8x plus 40 will equal 8. I've got all the variables to one side, so now I want to try to get all the constants to the other side. So I need to subtract 40 from both sides. We're left with 8x equals our negative 32. And when I divide both sides by 8, that's going to leave us with a negative 4. So there's nothing to this equation other than just some of the basic stuff that we've done. There's just multiple distributions and x's on both sides. So some things to be careful with. This next one, we've got a fraction. But I want to point something out with this problem. I want you to notice that the denominator of this fraction, and by the way, I could definitely solve this just like a normal fraction equation. And I'm going to show you guys that you could definitely do that in just a second. But I also want you to realize that when that denominator of the fraction is something that both of the pieces inside the parentheses are divisible by, so for example, 9 can be divided by 3 evenly, and 6 can be divided by 3 evenly. When that happens, if you want to, instead of just clearing the fractions, you could just distribute the fraction and it will go away as long as the number inside of there is divisible by 3. So that's just another approach to this problem. And you can get out your calculator if you don't trust me on this one, but go ahead and if you type in 2/3 times 9, what you're really doing is taking 2 over 3 times a 9 over 1. Top times top would give us an 18, and bottom times bottom would give us 3, and 18 divided by 3 is just a 6. So if you distributed this, you would get a 6n. Now, same idea over here with when I take 2/3 times our negative 6. So 2/3 times a negative 6 over 1. Top times top would be a negative 12 divided by a 3. That's going to end up giving us a negative 4. Notice that just when I distributed that fraction, it went away. When you see that the stuff inside of the parentheses is all divisible by that denominator, you can distribute, and that's just another strategy to those fraction equations. Now, will that happen every time? No. But we will get some practice with that today, seeing that, just being aware of that. Could I have multiplied everything by 3 instead and said, okay, 3 times this quantity, canceled out the 3's, 3 times the 4, gotten a 12, and 3 times our 2n, and gotten a 6n? Absolutely. Your answer, you're just going to have more simplifying in your final answer, but it's no different. You'll get the exact same answer either way. All right, so let's see where we were. We said on this side we got a 6n minus 4. On this side, when I distribute on my my right-hand side, I'm going to get a 4n plus 4, and then still plus our 2n. And I noticed that there are some like terms to combine on the right-hand side, nothing on the left-hand side, so still a 6n minus 4, and it's equal to a total of 6n plus 4. Okay, well, when I get all my variables to one side, I notice I'm subtracting a 6n, but from both sides, they end up canceling all of the 6n's out. This is one of those special cases. We talked about either it being an identity with all real number answers, or that it could be no solution. In this case, if we bring down what's left, we had a -4 is equal to our +4. That is not a true statement, so this one is a no solution. You may also see some if it was a true statement where it could be an identity with all real number answers. So there's some different scenarios when we've got all those variables canceling. All right, this next one is another fraction equation, but notice on this fraction equation again, the stuff inside the parentheses after that fraction, 21 is divisible by 3, and 18 is also going to be divisible by 3. So you could clear the fraction by multiplying everything by 3, but I'm going to tell you guys that this one again, if I just distribute that fraction, it's going to go away. So when I take 1/3 of 21x, that's going to leave us with a 7x. And again, if you're not sure, type it in your calculator just to check me to make sure that you're seeing this stuff too. And then our 18 divided by 3 is going to give us just a 6. On this side, nothing's changing. I still have my 23, but now I can distribute my -2. Sorry, I didn't really show that little mark over here. -2 times x will give us a -2x. -2 times a -5 would be a +10. And over here I can distribute the 9 as well. So 9 times x is going to give us a 9x. And our 9 times our -3 is going to give us a -27. Now, looking for some like terms. There's no like terms on the left-hand side. So that's still just a 7x plus 6. On this side, I notice I've got a 23 plus 10. So that's going to give us a 33. Minus our 27 is going to give us a total of 6. And then also we've got a -2x and a +9x. That's going to give us a total of 7x. So I've combined all my like terms. Now we want to get all the variables to one side. So I'm going to go ahead and subtract the 7x from this side. But whatever I do to one side, I have to do to the other. And I notice again that all of these x's are canceling each other out. There's no more variables. So this is another one of those special cases. The special cases only happen when all the variables are gone. If there are still variables, you got to keep going. Solve for x. But if they all cancel, and here I'm left with just something like 6 equals 6, that is true. A number does equal itself. That's an identity. That number sees its identity on both sides of the equal sign. So it's an identity, all real number answers. You could say that there's infinitely many solutions. So any number that I put into this equation is going to make one side exactly the same as the other side. All right, we've got another fraction equation. We've just done a couple of these fraction equations. All I want to do on this point is clear the fractions with you. I think you're going to be okay from that point on. Notice that here again, 16 and 8, -8 technically, are both divisible by this 8. So this is another one where I could just distribute that 3/8 through the parentheses and it will clear the fraction for me. When I take 3/8 times 16, that should give you a 6x. And 3/8 times our -8 will give you a -3. Equals our 10. We could distribute over here and get a -5x minus 10. I think from that point you guys would probably be okay. One thing I just want you guys to realize is that if you do have like terms on one side of your equal sign that end up canceling each other out, for example, I've got a 10 and a -10, that's okay. So this is really just a 6x minus 3 is equal to a -5x. So just some things to kind of be careful with. This next problem, notice that on this side, on the left-hand side, I have my 6 and 3. Those are like terms. There's nothing to distribute. I could go ahead and combine those and get my 9. And over here I have some like terms as well. So I still have an 8, but a -5x. Notice that all my variables already are all to one side. I don't always have to get them to the left-hand side. I can go ahead and keep working from here. I would just leave the x's over here and now just move the constant because I don't have any variables on this side to get them all to the same side. They all already are. So I would go ahead and subtract the 8 from both sides. That would leave us with a 1 is equal to a -5x and then divide both sides by that -5. And you end up with x is equal to a -1/5. Now, Could I have gotten all the x's to the other side? Sure. If you had added 5x to both sides, you would have had 5x plus the 9 is equal to 8. And then we could have moved our 9 to the other side and ended up with 5x is equal to a -1. And then when you divide both sides by 5, you still get -1/5. So you wouldn't have gotten a wrong answer had you moved the 5x's over. But just realize that you don't have to in this case. The last example that's on there, I'm going to go ahead and skip just because I think you guys are probably okay with this, and I'd like you guys to have some time in class to be working. Make sure you're listening to the sub, you're following directions, and that you're working on your homework during this time. I'll see you guys soon.